Okay, welcome back everyone. We're doing lesson 13F, which is all about reciprocal trig functions and their graphs. Now, in terms of actually you guys graphing them from an equation, we're going to look at that more in a future video. Today's really just going to be kind of understanding what a reciprocal trig function is and what those graphs look like. So you can see here in front of me, I've got the graph of sine x here, which has roots, or where it cuts my x-axis at, pi, 2 pi, 0, minus pi, minus 2. You will notice it's in general form. I've put that in more for you guys to kind of experiment. You can kind of play with the sliders a little bit, see how that impacts things. I've included a link to that just below this video on the OneNote. So if you want to click there, you can tick all these boxes. You can play around with the sliders. You can kind of see what they look like. Today, we're just going to keep it, or for this video, we're going to try to keep it nice and short and sweet. So as I mentioned, we have these 0 points. So if you imagine graphing the reciprocal, well, the reciprocal kind of meaning 1 over, and you can see I've got an equation for that just down here. If I graph 1 over sine, well, where I have these 0 points, I should get asymptotes because I'm dividing by 0. If I have 1 divided by sine, where sine is 0, I can't divide by 0. So I should get some asymptotes. If I think about what's happening here as well, as my point is kind of decreasing towards my 0, I'm dividing by a smaller and smaller number, which means this is going to get really, really big. So I should see my graph shooting up around the point where I have 0, and then just kind of cutting off or having a break and then going to the next point. So if a little think, maybe we can get a bit of an idea in our minds of what our graph looks like. And I don't know if many of you would have thought, but it looks like this. Ta-da! And it is what we described. You have these asymptotes here at the 0 points. You can see I have breaks in the graph, and towards this 0 point, it gets really, really steep. As it crosses through here, now I have negative values. So 1 divided by a negative number will give me negative values as well. That's why we have both the positive and negative quadrant being represented here. So this graph, this is a reciprocal trig graph, has a really, really special name because it's so useful to so many different equations. Now, the name we give that is called cosec. Now, unfortunately, on decimals, I can't write cosec because it thinks this E stands for exponential. But cosec on decimals is abbreviated to CSC. That's, you can see this function I've written up here. But it is called cosec nonetheless. If I tick that, you can see cosec is the graph of 1 over sine x. If I keep looking at this idea with my other functions, if I change this to cos, if I have my cosine graph and I want to look at my reciprocal trig functions for that, here you can see it's the same idea as it was for sine. It's just now it's a cosine graph. And again, where I have my zeros, I have my asymptotes, but now instead of, pi, 2 pi, it's pi on 2, 3 pi on 2 minus pi on 2, and my peaks still overlap because it's 1 divided by 1. So that's going to work as overlapping just here at my peaks and my troughs. If we draw a graph of tan, well, tan already has its own asymptotes. So if I do 1 over tan, I get a graph that looks like this. It's almost mirrored. You can see we have kind of like a point of intersection here in the middle. And that is going to be simply when they equal each other. There we go. So you can see I've got these points of intersection here. You can see where I have my asymptotes. Now I do have a function. So the middle part of my new function kind of passes through where my asymptote would be for my normal tan graph. You can see I've ticked a lot of points there. We don't need to put all these points on when we're sketching. This is more just to give us an idea of what these graphs look like. So you can see there is the green graph is tan. The blue graph is 1 over 10. So these graphs are so special that we give them their own names. So I call the graph of 1 over cos, I call that sec. 1 over sine is called cosec, and cos over sine is called cot. Now, I already kind of explained cosec. Like I said, there's a lot of different names here. Part of the trouble that some students have is being able to understand which means which. And there is a little trick here. If I look at my third letter for each of these functions, that's going to tell me which function it is the opposite of. You can see my third letter is sec. So it's going to be 1 over cos, C for cos. Cosec, again, my second letter now is S, S for sine. And cot ends in a T, T for tan. The main confusion really is going to be around these two graphs, my sec and my cosec, because a lot of people think cosec, well, it has the word cos in it, so it should be inverse cos. That is not true. Read from the third letter. the third letter is an S, so it's 1 over sine. If you guys want to know the full name of this, sec stands for secant, cosec is cosecant, and cot is cotangent. You don't fully need to know what those names are. We will always be essentially addressing them by their nicknames, sec, cosec, and cot. And again, just note, you might see cosec written as CSC. And again, my middle letter at that point is the S. However, in exams, always write cosec because that is the official name. It's just some coding, like your graphics calculator, for example, might refer to this as CSC. So that's pretty much it for understanding what these graphs are. Sec, cosec, and cot are reciprocal trigonometric functions.